Every time a consumer lathers up like a classic alkaline bar soap and washes their face, they aren't just cleaning their skin. They're dropping this massive chemical bomb on a metropolis of over 3 billion living organisms.
Yeah, it triggers a total ecological collapse that takes hours to recover from.
Right. And, we're trained as formulators to treat the stratum corneum like it's this blank, sterile canvas. We prep it, we strip it down, and we paint our actives on.
Because we just expect those molecules to behave exactly as they did in a sterile petri dish, which is, well, it's just not reality.
Exactly. And that's why we're doing this deep dive today. If you're listening to this, you are an ambitious cosmetic chemist, a formulator, or, a product development specialist.
You're the one actually standing at the bench, writing the briefs, and building the architecture of the products.
So our mission today is to cut through all that marketing fluff. When a brand just slaps Microbiome-Friendly on a standard emulsion, we want to get down to the hard biological mechanics of formulating for a living ecosystem.
And our roadmap for this is, it's a really incredible masterclass by Dr. Ari Masudi.
Yes, the former researcher in regenerative medicine.
Right. And he's now a business consultant specifically for the beauty industry.
Right.
And his core thesis, honestly, this should be printed out and taped above every homogenizer in your lab.
Seriously.
He says the skin microbiome is not a fleeting marketing trend. It is your next primary formulation constraint.
Because Dr. Masudi makes it so clear that every single product you develop alters the skin's ecology. You literally don't get to opt out of that.
No, you don't. The only variable you actually control at the bench is whether that alteration is an intentional positive design choice or just reckless collateral damage.
Okay, let's unpack this. Because treating all skin as a homogeneous surface, dropping a rich, heavy lipid emulsion on every part of the body, it's basically like dropping a rainforest plant in the middle of the Sahara.
That is a perfect analogy because the microenvironments of the skin are wildly diverse. We're talking about over 300 bacterial species.
Mostly dominated by what? Cutibacterium, Staphylococcus, and Corynebacterium.
Yeah, exactly, alongside crucial fungi like Malassezia. And these microbes, they act as the skin's ultimate security system.
They physically crowd out the bad stuff.
Right. They crowd out pathogens and they produce bacteriocins, which are essentially microscopic targeted missiles that punch holes in the cell walls of invading bacteria.
Oh, wow.
Yeah, but they are highly specialized. So Dr. Masudi divides the canvas into 3 distinct ecological zones.
Meaning formulating for the face versus the armpit shouldn't just be about, tweaking the packaging. It's about formulating for entirely different species.
Precisely. So consider the sebaceous zones, the face, the chest, the upper back.
The oily areas.
Right. Because these areas are pumping out sebum, they are dominated by lipid-loving microbes like Cutibacterium acnes and Malassezia.
They actually eat the sebum, right?
Yeah, they literally possess specific lipases to break down your sebum triglycerides into free fatty acids, which is, it's what keeps the skin acidic and protected.
Got it. And then you have the moist zones, like the armpits, the groin, the skin folds.
Totally different environment. High humidity, different sweat profile.
So you need completely different bacteria.
Exactly. You find bacteria uniquely adapted to thrive in that humidity, primarily Staphylococcus and Corynebacterium.
Okay, and the third zone?
The dry zones. Forearms, lower legs. These are ecologically fascinating.
Yeah.
Because resources like sebum and sweat are so scarce, the microbial density is lower, but the diversity of species is actually the highest on the entire body.
Wait, really? The dry areas have the most diversity?
Yeah, it's counterintuitive, but it's true.
So a generic microbiome-friendly claim on a body lotion starts to look scientifically absurd.
Completely absurd.
Because if a consumer takes a heavy, lipid-rich cream designed to hydrate a sparse dry zone and slathers it onto a moist or sebaceous zone,
they're fundamentally feeding the wrong resident microbes.
They might trigger an overgrowth of Malassezia just by giving it too much of the specific triglycerides it loves to eat.
Exactly. You have to build formulas that are ecologically coherent for their specific target site. It moves us way past basic categories like oily versus dry skin.
You're engineering a chemical environment for a specific microbial profile, which brings us to the formulators' saboteurs.
The stuff that destroys the ecosystem.
Right. But I have to push back here on behalf of the commercial reality. Consumers actively demand that tight, squeaky clean feeling from their cleansers.
Oh, I know. They associate it with it working.
Yeah. So why does Dr. Masudi argue we need to actively surface conflicts with clients or marketing teams who want a classic alkaline natural soap?
Because that tight, squeaky feeling is literally the physical sensation of barrier compromise and ecological collapse.
Wow.
And the primary driver of that collapse is the single most actionable variable you control, pH.
The skin's ideal pH is around 5.5, right?
Yeah, roughly 5.5. And that acidity is a highly engineered biological defense mechanism. It's maintained by those microbial-free fatty acids and lactic acid from sweat.
And the enzymes produced by our good bacteria, like Staphylococcus epidermidis, are perfectly optimized to function at that exact pH.
Right. So when you introduce a classic bar soap sitting at pH 9 or 10, or even a gel cleanser at pH 8, you're dealing with a logarithmic scale.
It's a massive spike in alkalinity.
A huge spike. At that pH, the enzymes of S. epidermidis denature. They just stop working.
Yeah.
They can't adhere, they can't replicate.
Well, the pathogens like Staphylococcus aureus suddenly find an environment where they can rapidly outcompete the good guys.
Exactly. And Dr. Masudi's data shows this shift disrupts the microbial balance within hours. The barrier weakens, water loss accelerates, you get inflammatory flare-ups.
So formulating a cleanser at pH 9 and claiming it's good for the skin is just a biological contradiction.
It is. The baseline has to be Sindents or tightly pH-adjusted gels kept strictly between 4.5 and 5.5.
But it's not just pH driving the collapse, is it? We
Yeah.
have to look at the collateral damage from surfactants and preservatives.
Oh, absolutely. Classic anionic surfactants like SLS are entirely indiscriminate.
They don't just lift dirt.
No, they aggressively emulsify and strip the vital intercellular lipids. And those lipids are the literal food source and structural habitat for the commensal bacteria.
So repeated exposure just creates this ecological crater,
Yeah, leading to a long-term drop in diversity.
which is why the pivot to milder glucosides or amino acid-based surfactants is so important. We know how to clean without taking the lipid matrix with.
Exactly. But preservatives are a much thornier issue.
Because we legally have to pass challenge testing, we can't sell contaminated emulsion.
Right. But standard broad-spectrum systems like MIT or parabens or phenoxyethanol, they don't just vanish when they leave the bottle.
They keep working on the skin.
They behave like a bulldozer in a garden. You eliminate the weeds in the bottle, sure, but once applied to the skin, that bulldozer keeps running.
It takes out the topsoil, the flowers, everything.
It kills the resident commensal bacteria for as long as the product is on the surface.
So how do we balance microbiological safety in the jar with ecological safety on the face?
You start evaluating a preservative's specific footprint on the microbiome, especially for leave-on products.
So looking at alternative systems.
Yeah, Dr. Masudi highlights using multifunctional ingredients like lactic acid, which naturally lowers pH and acts as a postbiotic, or fermented radish root extract.
So you're calibrating your hurdle technology to prevent mold in the water phase without acting as a broad-spectrum antibiotic on the stratum corneum.
Exactly, it's about precision.
Okay, so knowing what to avoid is half the battle. We stop dropping pH 9 soap and bulldozers onto the barrier.
Right.
But the real challenge is how we intentionally build and support the ecosystem. Because looking at marketing briefs today, the terminology is just a mess.
It's everywhere.
Prebiotics, probiotics, postbiotics, they're thrown around interchangeably. As a formulator, how do I actually map my actives to the right category?
Well, what's fascinating here is the distinct biochemical function of each one. Let's start with prebiotics. These are the nutritional substrates.
The food.
The food.
Yeah.
Complex carbohydrates, things like inulin, fructooligosaccharides.
But wait, if prebiotics are essentially bacterial fertilizer, how do we make sure we're only feeding the S. epidermidis and not, like, accidentally throwing a buffet for the pathogens?
That's a great question. It comes down to enzymatic locks and keys. Pathogens often lack the specific enzymes required to break down these complex oligosaccharides.
Oh, interesting.
But S. epidermidis possesses the exact enzymatic machinery to metabolize them. So it selectively feeds the beneficial resident, letting them multiply and physically crowd out the pathogen.
So for the lab, prebiotics are kind of a dream. They're chemically stable, they don't mess with preservative efficacy, and you can just drop them in at 0.52%.
Exactly. No regulatory red flag, which is a stark contrast to probiotics.
Oh man, the industry plays such a massive shell game here. Because true, living bacteria are a nightmare to formulate under EU stability guidelines.
Nearly impossible. You need specialized, airtight, preservative-free packaging and maintaining a guaranteed live count on a shelf for 2 years. Forget it.
So when brands claim probiotic, what are they actually using?
They're almost always using lysates. Fragmented, heat-killed, dead bacteria.
I have to admit, as a chemist, the mechanism here always feels slightly counterintuitive. If they're dead and fragmented, how are they communicating with the human immune system?
They leave behind highly specific structural components, primarily peptidoglycans from their cell walls.
Okay.
And human keratinocytes have these specific receptors, toll-like receptors, that recognize these fragments.
So the skin still recognizes the dead bacteria?
Yes. When the lysate binds to the receptor, it tricks the skin's immune system into a state of heightened readiness and barrier repair. without the risk of an actual live infection.
That's brilliant. But your regulatory team has to make sure the packaging is honest, that they're non-viable cultures.
Exactly. You must label them honestly.
And then we have postbiotics, the
No.
metabolites.
Right, the lactic acid, short-chain fatty acids like butyrate, complex fermented filtrate.
So instead of relying on the bacteria to produce the good stuff on the skin, we just add the final output directly to the water phase.
Exactly. It offers the most practical formulation opportunities right now.
Okay, here's where it gets really interesting. We have all these specialized biotics, but Dr. Masudi highlights an ingredient every single chemist already has in their lab, niacinamide.
Vitamin B3.
Yeah, we throw it into formulas constantly for brightening, but it's actually a microbiome powerhouse.
It really is. The mechanism of action at 2 to 5% is fascinating. Niacinamide doesn't kill bacteria directly.
Okay.
Instead, it stimulates the skin's own keratinocytes to dramatically upregulate the production of antimicrobial peptides, AMPs.
Specifically things like LL37 and defensins.
Exactly. And those human-produced AMPs act selectively. They physically punch holes in the membranes of pathogenic bacteria while leaving the commensal strains largely alone.
And niacinamide just arms the human cells to do the ecological policing themselves.
Exactly. And furthermore, in the underarm zone, niacinamide specifically targets Staphylococcus hominis.
Which is the bacteria that cleaves sweat into those volatile thioalcohols, the stuff that actually causes body odor.
Right. So by targeting S. hominis without causing a broad-spectrum wipeout of the entire armpit microbiome, niacinamide acts as a highly intelligent, targeted deodorant active.
It manages the ecology rather than sterilizing it.
Precisely.
All right, so we have our toolkit. We know how to calibrate pH, select mild surfactants, optimize preservatives, use biotics and niacinamide, but consumers want to fix visible problems: acne, severe dermatitis, dandruff.
Right, and Dr. Masudi's framework forces us to view these not as infections to be eradicated, but as dysbiosis.
Severe ecological imbalances.
Yes, let's look at acne. The traditional approach is to aggressively sterilize the follicle with heavy antibacterials because we blame Cutimacurium acnes.
But sequencing shows it's not just the presence of C. acnes, it's an overgrowth of virulent pathogenic strains, while other phylotypes of that same bacteria are actually protecting the follicle.
Exactly. So when you formulate an acne serum using heavy occlusive silicones to make the texture feel nice,
You're creating a huge problem.
you really are. Virulent C. acnes is largely anaerobic. It thrives without oxygen.
So you're literally building an oxygen-free bunker over the follicle, giving the bad strains the exact environment they need to multiply.
The formulation architecture itself exacerbates the pathology. The solution is selective antibacterial activity, like azelaic acid, that suppresses the virulent strains without suffocating the skin.
And we see a similar dynamic in atopic dermatitis.
Oh, severe eczema is a catastrophic collapse in microbial diversity, up to a 90% total dominance of Staphylococcus aureus.
It just aggressively crowds out everything else.
So a simple humectant serum won't fix it. Your brief must prioritize barrier repair using ceramides and niacinamide, combined with postbiotics specifically chosen to suppress S. aureus.
You have to push it back so the natural diversity has space to return.
It's the exact same strategy for dandruff, which is an overgrowth of the fungus Malassezia restricta.
We can't talk about dysbiosis without mentioning the ingestible beauty trend. Glowing skin from the inside out. How mechanical is the gut-skin axis?
It's deeply mechanical. Systemic pathways connect the gut and skin. Short-chain fatty acids produced in the gut enter the bloodstream and influence skin inflammation.
But Dr. Masudi stresses that a generic probiotic blend won't cut it.
Not at all. You need specific, clinically studied strains. If you want skin hydration, the data points to Lactobacillus reuteri or Lactobacillus brevis.
And for reducing skin sensitivity and post-UV inflammation.
You need to be formulating with Lactobacillus paracasei. The precision is just as rigorous as selecting a topical active.
Which brings us to the biggest hurdle, the legal and regulatory side.
Oh, yes.
Because if I design this brilliant, ecologically coherent emulsion, but my marketing team writes, cures acne by rebalancing the microbiome on the bottle in the EU,
The compliance department will shut you down immediately.
because if it claims to treat a disease, it's reclassified as a medicinal product, right?
Exactly, requiring EMA authorization. To say a cosmetic, claims must be purely functional, like supports the skin's natural microbial balance.
But European regulators are demanding hard data on the finished formula now, not just raw ingredients.
Right, because once you mix a prebiotic into a complex emulsion, its biological behavior might change entirely.
So how does testing have to evolve?
Dr. Masudi outlines a clear escalation, baseline level, document the exact pH of every batch, and add S. epidermidis to your preservative challenge testing.
To quantify the collateral damage on commensal bacteria.
Yes, and for premium claims, the standard shifts to ex vivo testing, reconstructed 3D human skin models actively colonized with living bacteria.
Wow. So you apply apply the emulsion and track the molecular response.
You track bacterial adhesion, structural barrier gene expression like filigrin, and DEFB4, the gene for those antimicrobial defenses.
You can even track inflammatory cytokines like TSLP and IL-8, right?
Exactly. Showing your formula lowers TSLP expression in a colonized model is the gold standard. It proves your architecture is coherent with the ecosystem.
Okay, we've covered a massive amount of technical ground. If you're listening at the bench right now, here are your immediate next steps from Dr. Masudi's masterclass. First, audit your pH flag, any cleanser over 6.0 and any leave-on over 5.5.
Second, contact your testing facility and mandate S. epidermidis in your challenge testing.
Third, categorize your biotics accurately. Know exactly what mechanism you're specifying.
Fourth, align your formulas with the target skin zone. Don't use a sebaceous architecture for a dry zone.
And finally, phase out the bulldozers. Stop using alkaline soaps and indiscriminate broad-spectrum antimicrobials.
The future belongs to formulators whose products actually behave differently on a biological level. We have to design for the ecosystem from the very first brief.
For decades, the cosmetic industry's gold standard has been killing 99.9% of bacteria. But as you head back into the lab today, ask yourself this. What if the future of your greatest formulation isn't defined by what you eliminate from the skin, but by the microscopic forest you allow to grow there?